Hello, my name is Robbie Tribble, and today I'll be talking to you about my planetary project on exoplanets for my astronomy class. It is entitled Exoplanets, an overview of the unique characteristics of exoplanets beyond our solar system. What is an exoplanet, you might ask? The planets in our solar system orbit around our sun. Planets that orbit around other stars are called exoplanets. This diagram compares the inner solar system's planets to Kepler-62, a 5-planet system located about 1,200 light-years from Earth, which we discovered in 2013. Scientists do not yet know if the planets located in the habitable zone of Kepler-62 have a predominantly rocky, gaseous, or liquid composition. The atmosphere in these worlds may be able to support life. This image is credited to the NASA Ames Research Institution and JPL Caltech, and it shows comparisons to our solar system and the solar system of Kepler-62. Are we alone in the universe? This graphic compares the similarity of potentially habitable planets to Earth. Finding similarities to Earth has been the goal of many astronomers, and some believe the first planet pictured here, Gliese 581g, may have the potential for life. Finding giant exoplanets, to which there is abundance we have found, is much easier than finding smaller planets due to the nature of finding these planets, which measures the light obstructed when a planet passes by a star. There are many methods for finding planets that we will talk about later, but finding the chemical composition of planets is a trickier task. Pictured here, we see current potentially habitable exoplanets compared to Earth in its similarity. There are 6 planets here: Gliese 581g, Gliese 667c, Kepler 22b, HD 85512b, Gliese 163c, and Gliese 581d. And it shows on this chart when they were discovered, and like I said previously, their similarity to Earth. The uniqueness of Gliese 581g. Gliese 581g is 3 times the Earth's size and orbits a dwarf star much smaller than our own. It is closer to its sun and tidally locked. Only one side of the planet is bathed in light, while the other side is always dark. Its orbit around its sun only takes 37 days and may only support life on the lit side. This planet is one of the closest of the potentially habitable, only 20 light-years away. It is colder than our planet, with the surface temperature at -35 to 10 degrees Fahrenheit, if it had an atmosphere like Earth, which mixed with its tidally locked drawbacks makes some doubt the habitability of this planet. Were Gliese 581g habitable, though, we would weigh 70% more on the planet than on Earth, given its larger size and gravitational forces. We have no idea of the planet's composition or atmosphere, and these are only artistic renditions based on theory. This planet's existence is disputed. And here we show the size of Gliese 581g compared to the size of Earth. And also there is an animation that features Gliese 581g and its tidally locked revolution around its sun. Pictured here, we have an artist's depiction of Gliese 436b. Gliese 436b orbits its star 15 times closer than Mercury orbits our Sun, and the icy surface survives at high temperatures. Its surface has a temperature of roughly 439 degrees Celsius, which is 822 degrees Fahrenheit. How does solid ice exist at a high temperature of 790 degrees Fahrenheit above the melting point of water? At a size roughly of Neptune's, the gravitational forces compress the water vapor in its atmosphere into solid ice. This pressure prevents the ice from melting, no matter how much it burns. One orbit around the star takes only about 2 days, 15.5 hours. Pictured here, we see a depiction of 55 Cancri e. The parent star of 55 Cancri e has much more carbon than our Sun, and its composition is likely primarily carbon. Due to the pressures with an average maximum surface temperature of 4,417 degrees Fahrenheit, which is 2,400 degrees Celsius, this planet may have a thick layer of diamonds. It is so close to its parent star that it takes only 18 hours for the planet to complete a full orbit. The sheer mass of this exoplanet exhibits 8.63 Earth masses, and its diameter is about twice that of our planet. So how do we measure the chemical composition of these planets without being able to visit them or physically see them well? The most successful method for measuring the chemical composition of an exoplanetary atmosphere is the transit spectroscopy method. The transit spectroscopy method measures the fraction of stellar light that can penetrate the atmosphere at different wavelengths, thus discerning its chemical composition. Here we see an animation of different wavelengths being measured by visually measuring a star. Scientists and astronomers can discern the chemical composition by this process. And here we have HAT P7b. This gas giant, which is 40% larger than Jupiter, has high precipitation of aluminum oxide, corundum, on its night side. Corundum gems of rubies and sapphires may rain down on this planet, and like Jupiter, there is massive storms here, so it is likely that rubies and sapphire gems rain across the entire planet. This planet is 26 times closer to its Sun than Earth is to our Sun, and has a surface temperature of 2,000 degrees Celsius, which is 3,630 degrees Fahrenheit. HAT P7b has the first weather system detected outside of our solar system. And here we have pictured some rubies and sapphires found on Earth, along with a representation comparing Jupiter with HAT P7b. Pictured here, we have a representation of PSR B162026b. This planet revolves around two burnt-out stars, one a pulsar and the other a white dwarf. PSR B162026b B162026b is the oldest planet ever found, estimated at 12.7 billion years old. It has a mass 2.627 times larger than Jupiter and is very far away from the central pulsar it revolves around. It takes 100 years to make a full revolution around this pulsar star. This planet is 12,400 light years away from Earth in Scorpius's constellation and is the first planet found in a globular cluster. As you can see from the picture, there is a pulsar and a white dwarf in the background of this planet. This planet revolves around two stars, which is a very unique characteristic. Most of these planets discussed here are uninhabitable, but there may be many habitable planets. Roughly 22% of Sun-like stars have Earth-sized planets in their habitable zone. There is at least one planet on average per star, with about 1 in 5 stars having an Earth-sized planet in the habitable zone. Given the number of stars in our galaxy, there could be about 1 trillion exoplanets in the Milky Way. Many possibilities of potentially habitable planets exist in our galactic neighborhood alone. We were very surprised to find such a low-mass object so far from its parent star, said Dr. Simon Murphy from the Australian National University. There is no way it formed in the same way as our solar system did, from a large disk of dust and gas. This is 2-mass J21268140. This is a planet that orbits a red dwarf star, and it was found using the direct imaging method, which is a method used to find planets far away from its host star. This planet has both the longest and widest orbit of any planet found to date. Found in the Octans constellation, this planet is about 1 trillion miles, 7,000 times the distance from Earth to the Sun, away from the red dwarf. The solar system of this exoplanet is the largest we have found. The last exoplanet we saw was discovered using the direct imaging method, and there are other methods that are not as good at finding the chemical composition as the transit method we first discussed. Over 3,735 exoplanets have been confirmed to date. How do astronomers find exoplanets with all the methods available to them? There are 5 methods for finding these exoplanets. 1. Watching for star wobble, radial velocity. 2. Measuring dip in light, the transit method we discussed first. 3. Direct imaging. 4. Gravitational microlensing. And 5. Seeing minuscule movements, astrometry. TRES-2b, the darkest planet. TRES-2b reflects less than 1% of any light that hits it. Similar in size to Jupiter, this coal-black planet is less reflective than black acrylic paint. TRES-2b is also burning up as it orbits its star at only 3 million miles away. It is not clear what makes the planet so dark. There are hues of red that emit a faint glow. The darkened planet is 750 light years away in the Draco constellation. Experience the exorings of J1407b. J1407b has the largest ring system found in our universe. J1407b has been referred to as Super Saturn due to its massive circumplanetary system of rings, about 640 times larger than Saturn's rings. It is an exoplanet located 434 light-years from Earth in Centaurus' constellation, and is the only known exoplanet with rings like Saturn. If this planet swapped places with Saturn's, its rings would dominate the Earth's sky and appear many times larger than a full moon. Exoplanets. Conclusion. We have found many unique outliers in our vast and expansive universe through our journey into the exoplanets. We have found artist representations of snapshots of the distant past, with the light of other worlds reaching the eyes of astronomers as they share their findings with us. How they discover these worlds brings us to a new reality of what is possible in our universe. The methods used to give us all an insight into their findings show us what is visible through light. As we stare into the night sky, we can now vividly imagine the great mysteries of what is still unknown.